Hi guys, welcome back. So we are still looking at revising Euclidean geometry, right? We have been talking about the midpoint theorem. Now we're going to try and apply it to the last questions and see exactly how we can do that. So let's just jump right into what the question wants us to do. Now, the question says ABC is an isosceles triangle with AB being equals to CB, right? And if that is the case, we know now that this will be equals to that, right? Which means it's an isosceles triangle because it might be a midpoint somewhere there. And then also we will claim that that is equals to that, which the line segments. And then let's just quickly read the last part and apply what we are talking about. So D is the midpoint of AB, I've already showed that. E is the midpoint of CB, I've also already showed that. The last thing will be the midpoint of now AC, meaning this one here will now be equals to that one there. But what do I now know? I know that angle C is equals to angle A because they said it's an isosceles triangle, right? And then because I now know that, I can then talk about quite a few things that have to do with the lines being equal to each other and the angles being equal to each other based on the fact that they told me it's an isosceles, number one. Number two, they told me that there are midpoints here. So I just want to annotate this on this diagram. So if this is an isosceles and E is the midpoint of BC, it means EC is equals to BE. Remember that. Which simply means that also DB will be equals to DA. But now, do you realize that all four line segments will be equal? Because these two lines, AB and BC, are equal to each other. Do you see? And then lastly, I will have this one down here, which is equals to that one down there. So now you can see I have some interesting things that I'm going to talk about here, right? Firstly, I know that this angle here is equals to that angle there, which will be the same as that angle there because of corresponding angles. And then I just want to also label it as 1, 2, 3 like that so that we are clear on what we are talking about. So this will be 1, that is 2, and that is 3. This is 1, that is 2, and that is 3, right? And then I'm going to try and apply that based on what I've just done now, right? So I know that the angle D2 will be equals to this angle here because of the concept of alternate angles, right? But I also know that the angle E2 will be equals to that angle down there because of also alternate angles. Now you can see that based on that, I can always claim that the angle F1, right, just to label it, is equals to angle A because it's corresponding angles. By the way, let me just write all of this down so that it does not confuse you because I'm saying a lot of things. So S and R them. So firstly, I'm going to start by saying I know that angle EFC is equals to angle DEF, right? And my reason for this will be alternate angles. And then I also know that the angle EDF is equals to the angle DFA, right? Also because of alternate angles, right? So just remember to always indicate which lines are parallel. The lines that we are trying to use here will be DE is parallel to AC, right? But now what do I know? I know that the angle EFC is equals to the angle A, right? That is because of corresponding angles. And that is simply just because EF is parallel to BA, right? Midpoint theorem there. And then as a result, it simply means that DEF is actually equal to A. And if DEF is equals to A, it simply means even my D2, according to the diagram, which is EDF, is also equal to A. You see, then I can apply that particular concept there. So I will say EDF is equals to angle C first, right? We were given that, and then lastly it just simply means that angle EFC is equals to angle EDF, you see, because both of them are equal to A and C, which is an isosceles triangle. And then if these two angles are equal, it simply makes it an isosceles triangle. Guys, I know it looks a bit messy, but if you follow what you needed to do there, firstly, you needed to make sure you link my F1 according to this, which is EFC, with the A there, and then you link the F3 here with the C there, and then from there you can work it out from there. So that's just what you needed to do, although it's a bit messy. Now I want you to find another way. So this will be like your homework that I want you to do, right? Here I used the concept of parallel lines and midpoint theorem, and they told me that ABC is an isosceles. Now I want you to try and see if you can maybe prove a parallelogram there somewhere, or prove using another way to try and show that that is an isosceles triangle. And then what type of quadrilateral is BEFD? So BEFD will simply just be a parallelogram, right? And you will need to motivate this. To motivate this, I know for a fact that this line is parallel to that line. That is a given. I know that this line will also be equals to that line. So it means one pair of opposite sides, parallel and equal. You see, same thing that I've been using here, right? So one pair of opposite sides. You need to specifically say that it's opposite sides. Are parallel and equal, right? And then what quadrilateral this is, it is a palm. And my reason is what I've just given you there, right? So that's how you can talk about that. So the question says, if angle BED is 68 degrees, right? I'm quickly gonna fill it in here. And remember, we know that those lines are parallel. So in simple terms, I also know that that is 68 degrees there. Now they want me to find AFD. So to find AFD, which will be this angle there. So I want to try and find that. For me to find that angle, already that angle is actually equal to C because DF is parallel to BC. But let me write it for you first. So I will then say, firstly, BED is equals to angle C, which is equals to 68 degrees, and this is corresponding angles, right? Because DE is parallel to AC. And then from there, I also know that angle AFD will be equals to also angle C, which will still also be because of corresponding angles, but now because of different parallel lines, which is my DF parallel to BC, right? And then lastly, it means AFD will be equals to 68 degrees, and you don't need a reason for that because you would have just showed it in terms of algebra. And that's what you need to do. You just need to make sure you are clear on the parallel lines and the midpoint, the midpoints that are given. Now, please remember that with Euclidean geometry, There's what we call conjectures. These do not have proofs. It's just a statement without any reasoning. The theorems is what we've been trying to look at now, and that's what you guys need in order to make sure you understand what Euclidean geometry is all about. Guys, I know Euclidean geometry at times is a bit of a complex thing, but I promise you, if you always follow our flow diagram that I did with you, the flow chart, it will allow you to be able to know what to do after what and what and what, like that. So it will give you the order of the steps that you need to take. Guys, we've come to the end of our lesson. I hope you enjoyed everything that we've looked at. If not, I will do better next time, but I know I never do anything that you don't enjoy. Remember, mathematics is food for the soul. Until next time.